seems that we're live both on Twitch and YouTube, so hello everybody. Codeforces on the right, yeah, this is also working. I need to ping on Discord, but before that need to create a directory. This is 712. My templates there, my templates file. ACPB can be ready. There was some command with T, I remember. Huh. Maybe I forgot. Right, 2 minutes to go. I might hide the chat for the contest. Are we allowed to discuss spoilers in the chat? Good question. Good question. Okay, so let's say that I will put this rule at the top. Okay, what about this? Add me when you want me to read something from the chat. Otherwise, yes, spoiling is allowed, but not when you add me. I will later hide this text, but let's say this. But with that, no spoilers, please. With this, I mean that you can spoil with each other. You can talk about solutions in the chat. So you can make fun of me for not seeing something obvious, but I will not see it. I will only read messages with @Ericto. No, I didn't prepare anything to draw, but we need to start. Wish me good luck. Tips for beginners? Come on, don't spam. If one, they need to be the same. This might be opening in both. Here. For 0, I will always close the one with bigger balance. For 1, I will use the first half of ones to open and the second half of ones to close. If it's odd, then this cannot be done. I'm not sure if no is possible in any other case than this one. I think not, but I'm not sure. So better to just check it. There are two strings I create and there are two balances. If 0, then the one with higher balance. Let's say we return whether this is possible. Is swap constant for strings? I think it is. Just like for vectors, right? Yeah, I think it's constant time. Right, else this is a 1, and now it's important if done once is smaller than 1/2, because then both open, otherwise both are closed. Two yeses, one no. I will immediately submit because there is no penalty for wrong submission on the first test, just the limits are fine. Balance at the end. Why not just check it? I think that's unnecessary, but unless I make a mistake in this if, it shouldn't hurt. Well, not a good start. Would prefer to see wrong answer on test 1. If we have something like this, if the number of sames is odd, then can I do this? There will be some number of opens, some number of closes. Let's say this thing, in some order, doesn't matter. Now put somewhere, no, I'm quite sure that this is properly checked. Also, are samples strong in any way? What am I looking at? Oh, this 10 is not a binary string. Okay, I thought that there are 3 binary strings here. Okay. if I don't find a reason, I can make random tests and see where return false happens here, because I didn't expect that. So maybe I'll understand the problem better. Here I assume that A is greater than B, so I decrease this one. Yeah, that's fine. This logic seems fine to just compare the balance and try to make it more evenly distributed. This thing, it just wants to build up a big balance and then close it. It also seems fine. This is bad. Breaking, yeah. My logic seems fine. The code also seems fine. Let's go through the code. Okay, this size, maybe like double that for some reason. No. I'm just reading the code line by line. What's the distribution? 200. What about wrong answers? Okay, many strong people failed. Like red and maroon is even legendary red. If there were already a lot of submissions for B and C, I would right now skip this one. I would do B or C. But there were like 2 each, so I'm not leaving this one yet. How much is it worth? 500? Why don't I see it? What's going on? Is it ICPC style? Maybe in absolving it is ICPC style. 500. First time seeing me getting stuck? Come on, I was stuck many times. Okay, let's read the statement. Maybe I missed something. The definition seems standard. Maybe I print something multiple times. I print no here. Return false. I read the whole input always. As you can see, I'm generating random tests. I don't like that, but what can you do? I'm trying to see what are cases where those later return falses are triggered. Okay, this makes sense. So for 2 zeros, I want false to be returned. This is understandable. What about the next thing? Okay, so this other if never happens. Now what's the next thing? Brute force, I guess. I'm lazy, so assuming that input and output is fine, I will just modify the inside here. How do I do this? If they are different, then b minus minus, else b plus plus. If they are different, then b plus plus, b minus minus. Nope, this is here. Okay, that should be brute force. That just says yes or no. No, it didn't work. Come on, why? I said what happens with A, and then B should do the opposite. If 0, then different, else the same. 0, then different, else the same. I'm sure that here I messed up something trivial. Yeah, this is what I messed up. Compare A with brute, and in A now we just print yes or no. That was quick. Something smaller, please. Well, this is not valid. Why am I not checking here if they are negative? That wasn't tricky or something. That was... Okay, I expected this problem to be very tricky and my solution just plain wrong. Now, because I have a brute force and generator, I will run this for some more tests. It seems to work. And this is how you can waste 20 minutes. Hey, Tanish, no spoilers when tagging me. You see this text? You see this? You will be banned. No spoilers. Instead of brute force, isn't it a good idea to check the resulting string if it's balanced or not? Yes, but that would not necessarily find a mistake. You know, I expected that I wrongly say yes instead of no, or the other way around. What you suggested is something else. I decided that the brute force is easy to implement, so I went with brute force. I added this. Sometimes I here go to negative A and B, or B. Okay, B, free coloring. Let's close this, let's forget about it. Okay, Alice forbids one color, Bob chooses some unforbidden color and chooses a cell to paint it there. Alice wants to make a conflict, so she wants to make two adjacent cells with the same color. Is this again tic-tac-toe problem where we should focus on diagonals? Alice forbids some color, then Bob will choose something else. Let's say, okay, then we go here. How do I stop this from becoming purple? Maybe I should just not touch the first column. Well, okay. I think whenever I put some digit, it will detect it as a digit and will think that the whole thing is a number. Okay, let's say we go with color B here. No, 2 is more readable. Then if I forbid 2, it only helps because Bob will put here 1. What if Alice keeps forbidding the same color? Let's say Alice keeps forbidding 3. Then I will keep putting here 1 and 2. Now, this is the situation. And she forbids 2. And I can put 1 here. She forbids 1. I will put here 2. I think we go diagonal by diagonal. And we always either we have here an empty diagonal and we can start with something. Maybe this. At most 2 diagonals will be started and they will be with different colors. So always one of them can be expanded, or maybe I finish one of them, so I will move to the next one. What happens at the end of the game though? Because I jump through diagonals, maybe everything will be taken. Let's say that taken is, this is a bit too big. Let's say that taken is an X. And here I started this diagonal with a 2, and now Alice forbids me from using a 2. But maybe I used 2 different colors here and there. Like this is 1, 1, 1, 1. This is 3, 3. What happens now? Now only 2 can be put there. So I lost. So here I need to use 1. I cannot put here 3. Can I just use 2 colors? Can I just try to achieve this? Let's think. Let's say that I started here a diagonal with 1. Now if 1 is forbidden, I will just start putting 2's here. Let's say that 1 is still forbidden, I will put here 2. But now, if 1 is still being forbidden, then I can put here whatever, because this is surrounded by all the neighbors. Okay, so I will make this pattern. And once it's impossible, once some operation is impossible, it just means that everything, all the remaining empty cells, they have all the neighbors fixed. So also one more color is allowed. So I think done. Let's call it bet instead of forbidden. A bet is from 1 to 3. I also print 1 to 3. Yes, I do. And I print row and column. If not taken and this, then I will put it here. I need here something general, some function, and I will say do I just print the row and column? Oh, the color as well. Instead of done, I will just do this. Color is this. Then row and column. I will need to increase those by 1. And let's say that the color also. Let's just operate with colors from 0 to 2. And then here I can remove that, this, that. Okay. If this is the case, then I believe that, oh, and now this is bad because I mark multiple cells. Then we can go again and find any empty cell. Maybe it will be less trivial to say what to put there. Question mark, row, column. But I claim that here all the neighbors are taken. There's this. Right, one last thing is to choose the color. This is the remaining color. I think think so. And as always, there is no penalty for wrong submission, for wrong answer on the first test. So especially for interactive problems, don't waste time running that. You will spend a lot of time this way. Cool, accepted. I see that the chat is quite active, but again, I only read messages with @ericto, but please don't put any spoilers. Okay, see. Obviously, with this distribution of accepted, it's only reasonable to do C right now. Maybe read D. And standings. I'm not looking very strong right now. 250. If only that part was the cost, then the whole round trip, do we get back? Yeah, return. The whole round trip through all the cities would cost 0 in total. So we only pay by maximizing with C of I. If we never hit C of I, then we would be fine and the answer would be 0. I need to make those two values, I think, similar. Like if C of I is, say, 15 and A of I is 5, then what? I will have maximum of 15 and A minus 5. So I want this to be 20. Perfectly, it should be greater than 20 or 20. I really don't want this to be smaller than 20. It seems to be some kind of matching, but a special kind of matching where we need to create one big cycle. So this should be 20 plus a little bit. Of course, it could be 50 as well, but I don't want to waste a big value of AJ to be used right now. In other words, I modified the problem a little bit to say that because the sum over AJ minus AI is 0, then it's enough for me to maximize, to care about the sum over this, because sum over this is equal to the answer. And this is why we have here 20 minus A of J. So what I need to do is overwrite and say that new C of I is C of I plus A of I. And then we have this. every city has some output value, C of I, and should be matched with some kind of A of j, the best possible one. And that's it. And now what? We will sort them by something. It seems reasonable to sort by A. But how will I construct this? I'm a bit scared that something greedy will construct disjoint cycles. So then the only way to make it connected is to start from some city. I think arbitrary city should work. And just keep taking the best possible not taken city. What is the best possible? So this is when I go from I to j. From I to j, I first made that operation. And now from I to j, I do this. So I look at C of I at the current city, and I'm looking for the biggest A of j not exceeding C of I. But is there anything bad about right now taking this? Well, this would give me +1 to the answer. This will give me 0. So now, do I take this guy, or do I take, let's say, G2, which is 27? And does the answer change? Does the decision change when I have the decision between those two? I pay 0 for going to this guy. But this big value is kind of wasted. Later I might have somebody with C of new I equal to 26, and then 27 would be perfect. Or just 27. If I am to visualize this problem, I would have some intervals, but I don't see how it's useful. Like C of I is always greater than this. But after that, now this is true, actually smaller than or equal to. So we have intervals. There's every I corresponds to some interval from AI to C of I. And then this cost is just by how much you need to go from the right endpoint to the left one, but you only pay for going to the left. I can draw it. Maybe it will help. If you use this one first, then second and third, you pay here this cost of going to the left. No, that's not true. The right part is CI. You pay this. So from 1 it would be better to go here. And we want to minimize this cost. then actually I shouldn't minimize a of j or maximize. I think it's, if 0 is never hit as the maximum, then I will have just the sum over this as the answer. And now the fact that I will ever get maximized with 0, that will worsen the answer. So I need to avoid this if possible. That will give me the best possible answer, actually equal to 0. And whenever I have this, so whenever possible, I need to go from Ci to some aj on the left. Is it guaranteed that it's always possible? Maybe it is, because the collection of Ci's is on the right. But then the answer would just be 0. Maybe at most once I will go not to the left. Like here, I will never be maximized with 0 because those right endpoints are only to the right from left endpoints. Maybe I'm thinking wrong. Also, if somebody is spamming in the chat, I don't know if that's the case, then let me know by @ing me, so I will take a look. The sum over this is constant, and I cannot do better. I cannot do smaller than that. This, but I can also say the sum over this is constant. That's 0. It's actually bad if I use all those CIs, right? CI is this part. I try not to hit it. I try to get the answer 0 is perfectly when this happens. So I try to get 0 whenever possible. So I try to make this negative. And this is negative when a of j is bigger, which is rarely the case. I don't know. I can now try a few random, not random. I can try a few greedy solutions now. But to make everything connected, the only thing I can possibly do is just start from one node, and keep taking greedily the best guy. Like now take the biggest AI, not exceeding this. But it's scary. How is it going with submissions? This is much more important tab than standings, by the way. You shouldn't keep refreshing standings. You should keep refreshing this page. And it says that it is reasonable to keep doing C. Is it true that at least one we will hit CI? It is. Because eventually we will go from smaller to bigger, or from bigger to smaller, and then that's negative, assuming there are no ties, and then we hit CI. Okay, that matches my interpretation here, so at least I think I'm not bamboozling myself. N is quite small, so matching would be possible. A fast matching algorithm, but then no costs involved. Let's look at this drawing. We pay for going to the left. Doesn't matter here what's the order. So if it's, say, 1, 2, 3, then I will only pay by going from 3 to 1. So I will pay this distance. Now instead, in a different color, if I say 1, 2, 3, I will first pay this and then pay that. So the blue order is worse. White was better. Which means that if the solution is indeed greedy, starting from anywhere, then for 2 it should decide that I should now go to 3. For 3 it should decide that we should go to 1. This is tricky because looking from 1, it's not that directly going to 2 or 3 is one of those is better, because the cost is either way 0. But later it turns out just the order 1, 2, 3 is better than 1 and then this guy on the right and then this. Because that would be equivalent to the blue order. And then obviously if there are more intervals here, there is here just one possible order. 1, 2, 3, 4. I mean one optimal order. Maybe not obviously, but I think that's the case. So if we start from here, I need to say that the next guy to the right. I think that when we are at some kind of C of I, we need to, among intervals with bigger aj, so those starting here, I need to take the first one, the one with smallest aj. And if that's not the case, if there is nobody here to the right, then I go to the left as far as possible. In this case here, if those didn't exist. Let's try to break this. Let's say we are here and there is nobody on the right. Now, is it okay to only look at left endpoints? There are two guys that are tied. Does it matter which, or maybe there is a small difference between them here. Should I care where they end? I will have now the same cost to them. And now if I say that this one is next, then he will need to go there with a big cost. And instead I should say that this one should be next and the cost is much smaller. This is by far better. So no, it isn't correct to just look at AJ. And later from 3 I will go to the right, but this doesn't have any cost. The cost is 0. Maybe I should magically sort by something like the sum of AI plus CI. I want to see running times. They are not huge. I don't think it is matching, but also a lot of them is few hundreds. So is it some kind of segment tree to make stuff to make decisions greedily? Maybe. And if you're confused by drawings on the right, CI, I first modify like this. And then I say that the cost is CI minus A of J when going from I to J, maximized with 0. Maybe I should sort A's, sort C's, and just say that some kind of magic is possible and I can easily compute the answer without actually knowing the order. Here, grab those left points, write down their coordinates, maybe 2, 3, and I don't know, 10. Then focus on the right endpoints, write down their coordinates, 5, 7, and 16. And do something with this. In other words, I'm basically saying maybe it doesn't matter that we will create cycles. No, that's not good, because here I would just say that 3 matches with itself, 2 matches with itself, 1 matches with itself. So the answer would be just the sum of lengths of this, when that's not allowed. I got this idea below from the fact that the answer here is just the biggest guy minus the smallest. Which makes sense. Like I need to eventually travel to the left. And here, I need from this guy to move to the left. Also, here there is some leftmost point. I need to get here at least once. What about if there is something here? Okay, I need to travel this distance, and maybe additionally, if somewhere there are double the white intervals, I need to also travel this one. So this, change the color, this purple thing and this purple thing. Maybe the sum of those two is, maybe this is the answer. And in general, it's leftmost until the rightmost, plus I need to multiple times travel everywhere where there are white intervals, with some intersection, with some non-empty intersection. So now the question is, no matter what's the alignment of these two with respect to each other, like maybe this, maybe like that, and a few other possibilities, then can I indeed achieve that here only this will be extra part? Let's think. So I go from the left. If I get here, and I travel there for free, get here, travel there for free, and then I need to travel to the right. So if there's only those two plus something there, I'm good. Now the bottom drawing. This is for free. No. Yeah, here it doesn't work because either I need to travel like that or I need to travel like this. So, nope. What else can I do? For everything I can find the best next interval, but I think I already disproved that approach. Where, yeah, it was here where the decision between 2 and 3, or maybe it was there, it shouldn't be greedy right now just by looking at my distance. And I believe that symmetrically it's not that for everything I should say what's the best previous step. Because I think it's symmetrical. Maybe not, maybe. I think it is symmetrical. Okay, I still don't know how to solve this problem. Maybe time to read another one. But 200 people solved it. That's a lot of people. I will read D to see if I like the style of a problem. And depending on that, maybe I will get back to C, maybe not. Well, here we need to analyze what is happening, what is possible. Seems similar to the previous one. Is working at Fang company really that desirable? I don't know, you tell me. But I don't want to go into that right now, I'm busy. I think you will find the answer to your question somewhere here. In FAQ, I'm sure that I also described my thoughts on Fang. Actron, you will be banned if you spoil me something. Read thing at the top. Please don't tag Eric though. Thank you, Arvin, for tagging me. Yeah, I need a fresh approach here with C, so let's think for some time about D. Maybe I will get back. Is it always possible? No, it's not always possible. I think that I wanted to say that maybe we should represent this as points. Maybe not. Like, you know, if A and B are coordinates x and y, then values x must keep increasing, values y must keep decreasing. So, you know, the sequence must be like this. Maybe not that regular. It can be, of course, more like this, but still, x is decrease when we go. Sorry, y's decrease as we go to the right. Every card has two possibilities of how it looks like. So actually, those are pairs. Like either we choose to use this point or this one. We've reversed x and y. I mean swapped x and y. And then also there is this point, and it's here swapped. Now, given such colorful pairs, maybe we can easily say if the answer is -1. This is one pair, and when you need to choose one of those points. If there is something here with smaller x and y, and this is also smaller x and y, and you cannot do anything. Okay, so here's an easy theorem, an easy lemma. -1 is only the answer if there is one pair strictly smaller than the other pair. So both coordinates are smaller. That's also the case here. 1, 2 versus, for example, 3, 6. If that's the case, then it's trivial to check if the answer is -1. Might in algo, again, if that's some kind of spoiler, don't. I thought that text at the top is not, I mean, I don't know. Should I write something else here at the top? Chat, tell me. You can tag me to suggest a better text. All right, if that's not the case, then what? Then always one of the 2 points is the better one, because it's by default there, it doesn't cost. And you can pay to switch. When is the arrangement bad? Well, the arrangement is bad because the final maybe the points will look like this, like roughly. So this guy would be here, and this doesn't work well with those. But if you decide one of them, I'm thinking that maybe it's good to decide one point kind of in the middle, and then a lot becomes obvious. I mean, for one eye, maybe it's good to decide whether we flip it or not, and then something will become certain. There is some graph of dependencies here. Maybe I should think about it as 2SAT. There is some graph of dependencies. So what is an example pair of bet? There must be two pairs such that they don't work together well. Let's say that one pair is here, and now this guy doesn't want anybody there. Damn it. So it must be those two together. Wait, here. Those two together or those two together. One possible combination is this, the other one is that. But wait, didn't I? Oh, no. I said some bullshit about -1s. When we look at this white, -1 is the case if both are strictly smaller. Okay, if even the bigger out of these two is smaller than the smaller out of those two. That's the theorem. I'm not sure about that, I'm just hoping it. Change the background color to something eye-catching, red, blue. What? Why? Background shouldn't be catchy. Or the message. Let's see. Is it really a good idea? The message will become harder to read. Like this, or text should be now black. Seems good? All right, thanks. So when I look at blue pair and white pair, I see that there are some dependencies there. And then there might be something yellow that works well with white, but doesn't work well with blue. And then again, it's this dependency or this. So yellow has two versions. I'm thinking about some kind of 2SAT still. So it's either this or that. And then there's blue. I mean, it's true or false. There's blue, it's also true or false. And then, let's say, those two can't be together. The color of an edge doesn't matter. But it also automatically means that those two can't be together. In other words, it just means that those two are equal, or let's say those two are equal, or those two are equal. I think that this is easy and square solution. For every pair of indices, you check if they should both be swapped or only one of them. Then you find connected components. Eric angry for me for pinging. Come on, stop. Okay, and now we need to do it in. So it's not even two-sat. It's just finding connected components and finding the smaller out of two groups. Some choice will cascade a lot of other choices, and then it's a choice. Maybe we have 7 flips or 9. Okay, 7 is better. Then how to make it more efficient? So I need to efficiently represent pairs where one point covers the other. And maybe we will be able to reach n log n with some data structure over the grid, over the plane. Because for this point, it doesn't like anybody in this quarter. This quarter can be represented by logarithmically many or log square many nodes. If I keep going from left to right with segment tree, then it's temporarily logarithmically many nodes. But with those segment tree nodes, I will have one-way edges, so it will become a two-sat rather than equivalency graph. Well, I can say, if I'm good, then you're bad. But then I'm maximizing yeses. In two-sat, can I maximize the number of variables set to true? I remember that we cannot count valid assignments. Can I maximize something? We have a directed graph. It's a, what is it, a DAG? I need to maybe draw a graph for two-sat and think what it represents. Yeah, I know it's a basic algorithm. There are some basic algorithms that I always need to think about. And then what? Assuming that I can do stuff there in two-sat. I sweep points from left to right, and right here put edges from me to all the nodes representing those intervals right now. But then the tree will be modified, so it's more like a persistent tree. Be right back. I will grab something to eat or drink. I'm the best. Oh yeah, that was very important for me to read. Still, I don't like this problem, even if I'm getting close. That's the type of implementation and thinking I don't like. So maybe now with a fresh mind, let's do C. But C and D are both doable. I see already that I'm doing very badly today. Hopefully I will do C and D by the end of the contest. All right. I like my idea about intervals. I think it's equivalent, so it's not that it can hurt a lot to think about it this way. Maybe. I think you get pinged even if people leave out the et. Oh. Really? Then that's bad. I also saw a series of oofs in the chat. I don't know if it was about my behavior or something else. I know I wasn't supposed to look, but it looked like a series of very short words. I'm looking at the intervals and thinking. You can program Nightbot. Maybe that makes sense. Not today for sure. Can it be anything different than the greedy approach of choosing the best next one or the best previous one? Yeah, can it be anything else? Yes, it might be something that doesn't find the order. Maybe we should just grab those values, mix them up, just like I said that maybe we should sort starts and ends, so left and right endpoints separately, and forget which one was which. One long interval containing another smaller one, I think it hurts, because you need to get to somebody from this one, and you need to get from somewhere to this one. Why did I say that this is a bad example? Maybe I was wrong about that? I was wrong about this. It's not a counterexample. I just here found a solution where the answer is the length of everything plus the doubled parts. I don't know. And I said that there are multiple parts here. What is on your background? No, it's a real background. I can hit it. There are a lot of wrong formulas over there. Okay, so now I don't have a counterexample to my crazy idea. So I can investigate more. Does it make sense that when I see 3 parts, I will say... So basically, when I saw 2, maybe they are not exactly the same, but at least some parts they are the same. And then I'm saying that at least twice I'm moving over this part to the left. Is that true? Yes, because at least twice I will move right here to the right. Oh, that's a nice way to look at it. Those are teleports. Every interval is a teleport from right to left, and it for free it teleports me. But I need to move back. I need to make a cycle out of them. I'm saying this out loud mainly to convince myself that this makes sense. Maybe while talking I will realize that something is wrong. I would also do it during the contest, but not with talking. Now, because it's connected, even if there is a gap, I need in particular to get from the beginning to the end. So let's say that also there's this thing here. There is a gap. This is the gap. But everything needs to be connected. So still, because I'm teleported from here to there, eventually I will need to cover this part to the right. Because everything needs to be connected, I also need to cover this part. Same here. Here, this part, twice I'm teleported for this part from right to left. So this, here and here, this is twice, this is 3 times. This is an obvious lower bound for the answer. And I just hope that this is equal to the answer. And because so many people solved it and I didn't have any other idea. I mean, I had, but they all didn't work. I mean, they didn't work correctly. I always found some counterexample. Let's just code this. Yep. And then pairs IC. Sometimes I see white wall behind. Oh yeah, I mean there's something behind, so when I don't put it up, then there is a normal room. This is the transformation from there, so that I would have an interval. A is the start of an interval, C is the end, I'm not even explaining that because it's a part relatively easy, relatively to the difficulty of coming up with this solution. I sorted 2n pairs of 2n events of +1 and -1. I keep the balance of how many intervals are open. And now always when I see a new accent, there is some balance. Even if balance is 0, I need to have a multiplier of at least 1 because gaps still need to be covered. Works on one sample. Works on the other sample, which doesn't mean anything. I will just double check overflows. Here I multiply two things. I highly doubt that they want something bigger than long. This is integer, this is integer. X minus, those are two positive values, so the difference will not exceed int. Yeah, should be fine. Okay, it would be pretty bad not to solve the problem just because I thought I have a counterexample. That was 1 hour, like 53 minutes, pretty sad. All right, 50 minutes left. And now, to be honest, if you look at my past performance in Codeforces, you will see huge variance. Because at this point, I can look at standings, but I don't think I need to do that. Yep, I see here ICP standings. I think this is some kind of bug in Codeforces. They don't display the Codeforces style scoring. Assuming I'm going with Codeforces style scoring, if I now solve D, I will not be top 50. I will be like 80th or so, even if I solve it fast. So what I'm going to do, and I always do that during contests, this is why I have big variance. I go for a problem with higher points. Sometimes I get it done, and then you will see me skipping a problem, and I will be top 5, maybe. But often it backfires, and then I'm like 200th. What are the points? Okay, I'm not touching F. F is not doable. So if I solve E, I will be in top 20. If I don't, I will be, I will anyway have a very bad place. That's my strategy for contests. Like F is not doable because of just the points. Right now it has 0 simply because there is not enough time passed. So like, if it was worth 3,000 points, still maybe this would be 0. But then I would try. Here F is not doable because it's worth 4,000 points. Everything long to make it overflow safe. Why not big num? What about that? Why not code in Python? A number in the output. You know what that might mean? Dynamic programming. Or maybe math. Math would be worse. I like this problem. For sure, I prefer to think about this one. In every row, blue is consecutive. In every column, yellow is consecutive. And things might be disconnected. There might be two yellows. Oh no, wait. But here, this is good. And I don't like the fact that they called it stupid. So stupid means good in this problem. But here, there is a row, the third row, where yellows create two intervals. Right. I even have those colors. I have buttons for that. There is blue is this button, yellow is this button. So I'm good. Now what remains is to solve the problem. Every column has exactly one segment of yellows. Okay, so let's say that indeed here in the middle there is a segment of yellows. Or let's say that this is the case in the middle. Then for every row, one part is completely yellow. In particular for this one. Because blue might be only on the left or only on the right. So this is yellow as well. Maybe this is also yellow and maybe this is yellow. I think this one could be also there. Let's go from the left. So the first column has this interval of yellow. Then there must be blue starting from here. Ending eventually. In every row there is one interval of blue. I think instead of coloring full cells, I should do something like that. Vertical yellow and horizontal blue. And here we have this thing where either, like, let's say in this column, there must be something yellow. It will be either here or there, which means that one of those two sides, it will be completely filled with blue. Maybe this one. Let's focus on filling yellow. Need to erase this. And everything not filled will be blue. Either I will go from left to right, or top to bottom. I think top to bottom is better. Let's say that in the first row I did this. I guarantee that the blue is satisfied here in the first row. It's just a single interval. Then I make some decisions about the second part. Well, this is a very easy polynomial solution for sure. What whiteboard? The software is called OneNote. The current row, the blue is from left to right, and for the blue part, let's focus now on this row. If I fill the second row like this, it means that, well, this is blue obviously, and now this is interval of blue from left to right, and then for each of those columns it's important for me whether yellow already happened here above. Or what about this? More like a recursive solution. We have agreed if we get info that this is yellow starting from the first row, ending here, then automatically everything here is blue. Maybe now I should say that I take two DPs, this thing and this one. For each of them, some bottom part must be, like for this guy looking from the right, from this guy looking from the left, it must be blues. The columns are independent still, each of them must have at least one yellow, but this is the only extra condition. So now what I think is that maybe we will compute for every n and m the answer. But then here I'm obviously introducing another requirement, the third thing in the input. But maybe those can be independent. Huh. Let's go full screen here. Maybe in the first column we have this. And it ends there. A lot of blue. Now I'm thinking maybe look at corners. There are 4 corners and maybe they need to satisfy something. If those blues, they are not monotonic, so one possibility is that they are monotonic. That's quite standard, I would expect that. If they are not, something is bigger than the next one, then here we have this special case where only one of those 2 parts can be yellow. Let's say that this is yellow. Let's say that this is yellow. From this we know that everything here is yellow as well, because blues in those rows were used there. Okay, but what if only this is yellow? That's perfectly possible. So nothing interesting happens as long as yellows keep decreasing from both sides. Did I try D? Yes, but only for a brief period. For the sake of my place, I'm now trying E. So maybe for some time this happens, but then eventually, for the first time, we have something longer on at least one side. And that triggers everything here to be yellow. In particular, everything can be equal to exactly that. Like this can be the finished drawing, everything else is blue. This is valid. If that's not the case, then what? Well, obviously nothing bad happens if those keep decreasing. But those 2 parts are now independent, this one and this one. So maybe it is smaller dp with some height and width and information that everywhere at the bottom there grows yellow. Same here, just when you flip the drawing. Now, will I be able to efficiently transition? Let's move to another problem. What are you talking about? Are you real nil? Because I'm doing a virtual participation. I'm solving problems in some order that I prefer. Let's briefly see what happens if we have, again, a grid, but this time we have a requirement that at the bottom we have just yellows. Then what? Well, for some time we will have decreasing intervals, then eventually something increasing, and this triggers the fact that this part is just yellow, so also this is yellow. So we get down to this smaller grid, also with information that yellows are at the bottom. Sure. If I move one by one like this, that's bad. Even here, that's at least 3 dimensions. I mean, at least n cubic. How do I make transitions faster? What's the number of ways in which I get from big grid into this smaller grid? So let's focus on some kind of target grid. This one, with bottom made out of yellows. What's the number of ways to get here? Well, we need to choose some decreasing sequence of yellows here. That's binomial coefficient. And then this, the number of ways to fill this gets multiplied by that. If it's multiplied, then I cannot make transitions fast unless I add some kind of FFT on the top of that. Is that viable? 2000, 3 seconds? Yes, I can do FFT. But I would prefer to avoid it. If I move from left to right, what's the state here after I'm done with those yellows? That's the current column, where the top yellow is, where the bottom yellow is. Can I say that they are in any way independent? Not really. You might notice that basically I'm experimenting with various orders of filling the grid. Right now I'm mainly doing it from left to right. But previously I tried to again focus on yellows but go from the top. And already for sure I had more than one n4th approach. I'm not sure if I came up with anything n cubic, but just this doesn't look good. I don't see a way to remove dimensions to keep something about this and that when going here from left to right. Maybe we will not compute the answer for all the smaller h and w's. The modulo is constant, so maybe for some h and w I will pre-compute the answer and copy paste and just put it in my code. For example, for single h, I could hardcode values for all the w's. Still, I would need to compute them. So here we had this. There is some interval of blue. Can I split this grid in some way to say that there are two independent parts? If not, then what? I had this idea about corners for some reason. If something is just yellow, that's easy. If here both of them are just blue, that's easy. Can I say something if those two are yellow and those two are blue? No, they do not intersect. If something increases, it cannot drop again. When I look at this sequence of bottom points, filler intervals, also how much time is left? 20 minutes. Look at sequence of bottom endpoints. If it's basically increasing, not decreasing, but when it drops, it cannot go up again. Go up, go up, go up, drop. What happens with the next yellow? Oh, do you need to just keep decreasing? Because the next one is either exactly there or it's until here, but then this was blue, so this cannot be. So it must be simply like that, maybe with some ties. Okay, what about the top part then? Because it dropped here, Uh, this seems to be kind of independent, like this, then eventually it increases, and then always increases. So we have two bitonic sequences. This is one, this is another. And that's it. The problem is almost count the number of ways to choose two bitonic sequences such that one is below the other. Like those. There are some extra conditions, like every row needs to have at least one blue, but I hope that those are details. For some time they will keep increasing, so only this part needs to be taken care of. From minimum of the top one to the maximum of the bottom one. If they don't intersect there, they will not intersect ever. I see how to make cubic number of states, but not quadratic. I'm thinking that maybe the difference between them is important. So it's like, if every current position is x, maybe it's dp of x and the difference between the two. Because the number of transitions to a smaller difference is kind of the same. Okay, if I am to solve this problem, it must be this dp. So let's just go with this one. Just yeah. Let's rely on this. So now, if the current difference is 5, and I have increasing part, no, the number of ways to get now the difference equal to 5 depends on where we are in terms of height. So no, just keeping the difference is not enough. Damn it, I hope it was it. This is useless now. This, sure, but not that important. And we are focusing on this right drawing. Now I'm thinking about inclusion exclusion. But that's not my strong suit. I need to be able to solve this problem. Count the number of two increasing functions limited by some upper height called n or m, whatever. Let's call it h, up to some kind of w. There's two increasing functions here. One always needs to be higher than the other. Can I do this? Oh, this one wasn't increasing here. There's this trick that whenever they intersect, if they intersect, let's say it doesn't matter that they are increasing. If they intersect, we could swap them here, the two intersected parts, so that now this part would become yellow and this part would become green, and now they stopped intersecting. Maybe it means that the number of if we count those with k intersections, then 2k paths, 2k pairs get into just one, actually, because one valid pair of functions, it actually produces 2k invalid ones, where k is the number of intersections, kind of. What I need is, well, I cannot count pairs of increasing functions in any other way than just to count increasing functions and square it. Can I do anything different? No. Okay, then I can count the number of pairs of increasing functions. Maybe what I should do is just look at the differences or slopes. So if eventually there is some intersection, how do I count it? Another thing is that I thought for a moment about Berle-Camp-Massey in this problem, but I don't know. Berle-Camp-Massey usually is useful when n and m are up to like million, and if you can solve the problem up to 1,000, then you use it to solve it up to a billion. And here it doesn't seem to be the case. X and y, if they both increase. If I take height of yellow and height of green as two coordinates, then also I can say that I measure the number of increasing sequences of points. Where the number of points n is equal to the width of the initial grid. The heights are limited by the height, and it's just that not necessarily for every x coordinate there is something, and there might be ties like this thing. Okay. So what's the x coordinate? Oh, the one is yellow height, the other is this height. So here I'm also limited by h. This is a square, h by h. In this square I need n points, and they need to be always to top right. How do I count that? Either with dp or with formula with combinatorics. Six minutes left. If I don't get a great idea in 2 minutes, I'm done. dp for a cell. That's not enough because I need n. For every n, maybe on what diagonal I am right now. No, that affects the number of possibilities. If I know the answer for every smaller n and h, does it help? No, because partial stuff isn't for smaller h, it's not a square anymore. I don't have any new ideas. It's hard not to give up now. A few more minutes. Okay, I can focus on sequence of x's here, sequence of y's. No, wait, what's going on? Oh, don't I also have a condition like everything needs to be below the main diagonal? That changes a lot. I wanted to say that the problem is easy and I know how to do it, because x's and y's are quite independent, but no, nothing can be there. Otherwise, you're just counting pairs of increasing functions. But here, whenever you would try to reach to something higher, you can kind of reflect it. The number of paths is the same. This is well-known combinatorics, I'm sure. Isn't it something like oh no, it's only when we have unit steps, but then the probability of staying here below is 1 over n plus 1. Maybe it's the same here. Yes, I will read the editorial. Maybe it's something like 1 over n plus 1 times everything. So maybe here, when I count those pairs of increasing functions that don't touch each other, the number of all of them is all of them divided by something simple, like n plus 1, something. Then I just use the formula for the number of increasing functions squared divided by something, and I say that this is the number of those. With that, I get this middle part, and then what? Yeah, then what? Okay, 20 seconds left. I tried. Right, chat. All right, chat. Now I can interact with you. I didn't do well. Radeusz and Marek Sokolowski, they both did both D and E. I did neither. Monogon did all of them. What a surprise in absolving. Yeah, I spent too much time on A and too much time on C. Can you go from left to right row by row? So if there is a yellow part and one side of yellow has a blue part, the other side must be yellow too. Like I'm not analyzing this now, but let me know if that's actually what I should focus on. On the right track for E, it needs some time. All right. Is there some easy formula like that? Didn't see all your work, but it looked like you were making the counting way more complicated than it needed to be. All right. Diagrams looked correct. So, am I right that we count pairs of bitonic functions with some detail extra conditions, where one needs to stay on the top of the other, and then the difficulty boils down to pairs of increasing functions, like this? No extra conditions, okay? And yeah, then my only idea is that it's some very easy formula, something square divided by an integer. Go back to the previous diagram. This one. I can name the diagrams. This is diagram A, and this is diagram B. Casework on those points in diagram A. Well, like on those two extrema. Okay, but I thought that the part, like this part, is very complicated, because I need to keep two decreasing functions. So I thought that everything here and there is trivial, but this part is very hard. What? Extrema happen in adjacent rows? What's wrong with this? This is a case where this is the case where they are not adjacent columns. Oh, blue in every row. Yeah, I thought that it's extra details and it will be about adjusting the answer at the end, or maybe focusing on first or last row. So this is not possible, because then there are rows with everything in blue. Yeah, like sure, if this doesn't exist, you know, everything I focused on here inside, so all this, everything here, all of that was about this part. I agree that those four paths, 1, 2, 3, 4, those are trivial, it's just some binomial coefficient. Okay. Nice problem. It's a very nice problem. I appreciated the fact that there was some condition, and then it turned out that we count pairs of Bitonic functions with some extra stuff. The extra stuff actually was very important because of this thing with two extrema being adjacent. But okay, that's a very nice problem. What else was there? And what is my place? I didn't quite get that. 315. If I solved D, I would be around 130th, let's say. So I stand by my strategy. I think it was good to switch to E. With E, I would be possibly 30th. For sure, I prefer to be 200 something and sometimes 30th rather than always 100th. Could you read F? Your proudest problem? I can read it. I wanted to first open the problem set. But if you want me to read problems, don't give them 4,000 points in Division 1 contest. In combined round, sure, 4,000 means that it's a standard Division 1E sometimes. But in a division round, in Division 1, it means something crazy. Okay, so my feedback about ABC. A, fine, it's a fine, easy problem. Of course, I suck, and I spent a lot of time on that. B, a little bit too easy in my opinion. Maybe just I got lucky. Sure, fine, easy problem. C, I don't know how much time I wasted because I found a counterexample, I thought, and I don't know how everybody else got to the solution. I spent a lot of time to get that idea. I like the fact that in my solution I don't really find the order. This is great. It's great that we compute the answer in some other way. But I don't like the part that I came up with a solution that I cannot prove. No, it's then about guessing and who is more convinced to their idea. Because for me, it would be much better if I didn't think about counterexamples and instead just once I got the idea, I would implement it. So I'm going to see the editorial for C, or you can tell me something about it now. D, I need to read the editorial for, or maybe first just quick look if it contains two set. Not this problem. No. Okay, I was on a very wrong track. Good resources for DP, my DP lectures on YouTube. Okay, so there's E, a very nice problem. D I cannot comment on, just because, you know, D, I have no idea. I spent 5 minutes. And F, okay, I'm reading F only because Monogon asked me. But I still think you shouldn't read this problem during a contest. Or maybe you should. I shouldn't. If it was geometry worth 4,000, I would try. So, okay, then I should have looked at this problem to realize if it's geometry or not. Maybe it is, so still I didn't read the statement. Balanced bracket sequence again. No, not again, integer sequence. Okay, so x matches with minus x. And the same is written here. Twin cards. The statement is fine, it's short and, let's say, natural. And what now? It's not that I will tell you something about the problem. I had the same thing to say after reading D. Yeah, it's a problem that you read and then you see that it's some kind of analysis. AdCoder loves those problems. They often have some kind of process where, okay, let's analyze a lot of stuff. So who says it's not geometry? Do you think it's a convex hull? I don't think that the ratios here are in any way important, but maybe. If I was doing better during a contest and I did A, B, C, D quickly, then I guess I would take a look at F before just going to read E. Just finish data structures and algorithms. What's next? I don't know. I don't know what is your goal. And you don't need to finish anything before solving problems on Codeforces. My advice is here. I will give you a link, and it doesn't include anything like read this and then that. Solve problems. I cannot tell you anything about this problem in a few minutes, but I believe that it's hard. I'm able to believe that. What were standings in the top? Also, how much time? 50 minutes to solve F. Then congratulations, Kevin. Resources for beginners. I don't know, read this. Yeah, read this and it contains also answer to your question. My confidence in geometry. It's not that I'm confident in geometry and I know I will solve it, but I'm better at geometry than I'm at strings, for example. So I should try to do geometry problems. Yeah, I think that E is a good problem. It's the best out of those 5. No. Is F similar to something you saw before? I think Monogon is not talking to me. In Russian version of the problem. Okay, never mind. Tutorial. By the way, the contest was about déjà vu, so I see that flipping was twice. How similar were the statements? Not extremely similar, but they're colors in a grid. What else do we have? Is this related to some other problem? Flip the bits. Well, TSP. Okay, I also did this. We can run Dijkstra. We can run Dijkstra. Yeah, okay. Nice. This solution is a good practice problem for anybody learning non-trivial Dijkstra. I might even give it to my students. So to everybody in the chat, if you're around, I don't know, purple in Codeforces, then maybe yellow. This is a good practice problem. Maybe even red, I don't know. Is this equivalent to what I did? It is equivalent, but I don't think we thought the same way. Then there's D and there's E. Okay, and here I don't think I should read the solution because I didn't spend enough time on this problem. So I think I'm done now. If I wanted to spend more time today, I would now implement E. I would finish the details first with drawing without the editorial, because after the contest I was told the extra piece of information that the two columns are adjacent, so now I can work with that. But I think I'm tired enough that I will finish. The contest was generally nice. I didn't do well, so my how I judge the quality of the contest might be affected negatively. But I enjoyed it. There were two aha moments. The first one was about two Boolean functions. The second one I didn't realize during a contest, about the adjacency of two columns. And if you look at standings, it seems that the difficulty was also quite good. That somebody solved even the last problem, but barely. So huge congrats. OEIS page for E? You think so? I don't know. The definition would be quite long. How many students I have? Mainly it's around, I don't know, 10 to 15 students in Poland. I and Marek Sokolowski, we teach them for free for Olympiad, the Polish Olympiad in informatics, and then IOI. That's most of my students. If you have more questions and you want to talk about private paid lessons, then reach me on Discord. Yeah, how to practice is just practice. But you know, I'm not the best, so if you want to actually win the world championship, then maybe you shouldn't learn from me. Okay, Monogon, thank you for the contest. I'm happy that finally I was able to do your problems live/record. For the past few rounds it didn't happen. And Monogon few times told me that, maybe not few times, but at least once, that he was so sad that in one contest of his I skipped few problems to then solve geometry, which was the last problem, and I didn't record that because I think I was on my laptop just outside of my apartment. So here you go. Finally, you are able to hear my thoughts about your problems. Monogon was better than OneGon. To be honest, I also think so. You offer paid lessons? Yes, but in very limited format. I mean, the limited amount. I have like, what, 4 students right now, maybe 5. And they are expensive. Magnitude of $100 per hour. That being said, you have so much content for free. You don't need paid lessons. One in the black. Does it look that nice? I mean, what about first reaching black and then changing your nickname? That might be a good strategy. And to be honest, any letter in black looks nice. Like, I had E for some time in the past, like 3 times it was for 1 week. And E looks nice as well. I'm sure that M would look nice as well. Oh, here you go. Does this look that bad? I don't know. I agree that one would look nice. Maybe then you should choose a letter with big volume, like to showcase the black. I don't know what is, maybe not volume, area. Okay, so what's the character with the most area? Maybe hash or at. Maybe at. I don't know if you can, I doubt that you can use at in your nickname. X-ray, yeah. X-ray is indeed suboptimal for maximizing the amount of black in your nickname. Is this FFT too? E has quite a bit of area. Uppercase letters might often be better than lowercase. Lowercase r seems bad. I mean, well, let's just see here. B is strictly better than P. M is nice because it's very wide. Maybe uppercase M is even better. I think so. So M might be much better than something like U, just because, you know, the number of times it travels up and down. And then also it might be better than E, because M has like 4 times the height. E is once the height plus 3 times the width. Is there an easy way with something like Paint to measure the area of something? So count the number of pixels that are black in a drawing. This is one character. Can I use it in my nickname? Tool for using rough work. What answer? What answer do you want? A hammer? Doing rough work. Float fill, but it paints everything. It doesn't give you the count. How to become LGM first? I have no idea. They need to make 3 in the rating black too. Yeah, I agree. Like, so why is this so strange now? Okay, the 3 in the rating indeed should be black as well. That would be nice. I don't know why they didn't do that yet. A lot of guys with uppercase E. All right then. I think that the best we saw here is uppercase M. So also uppercase W would be quite nice. I think that it beats everything else, including, for example, B, but I'm not sure. For sure, it beats E. So I think it's time to finish. Optimal nickname problem. Like optimal for LGMs, at least. I'm not saying what's... Maybe the second, then you should minimize the area of the rest of your nickname. So it should be M and then 2 very small characters, like hyphens or underscores. Like you should be called M underscore underscore, and then M will be black. Launch date? No launch date. W Erichton is next year? Sure, whenever I reach LGM again. William Lin, indeed, he has a W, an uppercase W. We? Maybe. I don't plan to change my nickname on Codeforces. I think it's a terrible nickname because it's hard to pronounce, it's hard to spell, so don't use something like that, but now it's too late. It's now a brand. W and M are the widest. It's not just the width we are looking for, but M and W, they travel up and down 4 times in total. M and W are at least 4 times the height, and height is much bigger than width. Oh, William Lin would be a good strat, but he is Team William. Alright, I see. So T is worse. Can you division 2 first? No, that would be boring compared to everything else we did. All right, guys. Thank you all for watching. Somebody doing Codeforces? I always try to, after the Codeforces stream, I just look here whether I should host somebody. Not this time. Then indeed, good night or have a nice day, Monogon. Thanks again for the contest. And see you everybody in 2 days. I will do some Google Code Jam practice. I will take an old Code Jam round 1 contest and I will just do it live. That will